substitute in the main equation, that is your force response. Y f of t is equal to y f of t is equation number 5, that is c1 cos 3t plus c1 cos 3t plus c2 sin 3t. One of you can help me the equation c1 cos 3t plus c2 sin 3t minus, tell me. Correct, no? Minus 1 by 7 cos 40. This was the equation that you got in the force response. In this, you will substitute the values of C1 and C2. C1 you got it as 1 by 7. So answer will be 1 by 7 cos 3t. C2 it will get cancelled because C2 is 0. So answer is 1 by 7 cos 3t minus 1 by 7 cos 40. This is your final answer. 1 by 7 cos 3t minus 1 by 7 cos 40 after substituting the values of C1 and C2 in equation number 5. What was your equation number 5? It was your force response. Force response is nothing but your natural response plus particular integral, particular solution. This is your natural response. This is your particular solution. Okay. So in order to find the natural response, C1 and C2, for that only we have applied two initial conditions and then we solved the values of C1 and C2. But since this is a forced response, you will take all the initial conditions as 0 and correspondingly you will find the values of C1 and C2 and rewrite our main equation. Okay. Okay, one more question I will do and then I will proceed to the next section. Okay. Similar to this, one more question I will do. Take down the question. Find the force response for the system described by. Find the force response for the system described by the equation. D square y of t by dt square plus 5 d by dt y of t plus 6 y of t equal to 2x of t plus d by dt of x of t, given that x of t is equal to 2 e to the power minus t u of t. So first I will go for the natural response. While finding the natural response, we need to write the characteristic equation after taking your input terms as 0. So in the RHS, you are having two terms, 2x of t and d by dt x of t. Those two terms will become 0. So you are having r square plus 5r plus 6 is equal to 0. After solving this, we will be getting the values of r1 and r2. Can you tell me the roots, characteristic roots for this equation? R1 and R2 after solving the quadratic equation.
So -2, -3.
R1 equal to -2 and R2 is equal to -3. So your solution will become yn of t. This is real and distinct, right? These roots are real and distinct. So your solution will be like this: C1 e to the power -2t plus C2 e to the power -3t. Let it be equation number 1. The roots are real and distinct. Therefore, I have written the solution in this particular manner. You have 3 different cases. You need to refresh all those cases before coming to the class. That is why the natural response yn of t has now become c1 e to the power minus 2t plus c2 e to the power minus 3t. Now we will not find c1 and c2 at this point of time. Before finding the c1, c2, we will go for the particular solution. So to find the particular solution, we need to check our input. What is our input? Input is 2 e to the power minus t, correct? 2 e to the power minus t. U of t will be what? Now based upon the table, you check the table of particular solution, whatever we have discussed yesterday, and tell me what is the particular solution.
K into e power minus t.
K into e power minus t, equation number 2. Now to find the value of k, we need to take our given equation and substitute accordingly.
But
So
for particular solution, we don't consider the second term, d by dt of x of t.
no. We will consider only your input term. You don't consider x, so d by dt, d square by dt square and all, you don't mind. Whatever your input, based upon that input, we are taking the particular solution. That is all. But in order to find the value of k, you will take the entire equation and then substitute. So to find k, take your differential equation, given differential equation. What is your given differential equation? It is d square y of t by dt square plus 5 dy of t by dt. See, one of you can tell me, it is very difficult. Go check back. Plus 6 y of t. What is the right hand side, Sayan?
Sir, 2x of t plus d by dt of x of t.
Okay. 2x of t plus d by dt of x of t. Now this was your given equation. In this equation, we are going to substitute our particular solution. So d square by dt square of k e to the power minus t plus 5 d by dt of k e to the power minus t plus 6 k e to the power minus t equal to 2. X of t is 2 e to the power minus t plus d by dt of 2 e to the power minus t. So we need to substitute x of t also in the right side. There are two terms in the right side. One is 2x of t and d by dt of x of t. Now simplifying this equation, since it is a second order derivative, what I will do, I will keep one derivative outside and I will apply one derivative. Derivative of k e to the power minus t is minus k e to the power minus t plus 5 into, again derivative of k e to the power minus t is minus k e to the power minus t plus 6k e to the power minus t equal to 4 e to the power minus t plus, will it become plus or minus? It will become minus because derivative of minus 2, isn't it? Minus 2 e to the power minus t. Derivative of e to the power minus t is minus e to the power minus t. That is why I put minus over there. 2 is constant. Now, when you observe this equation again, we need to apply derivative in the first term. So, your equation will be k minus k can be taken outside. Derivative of e to the power minus t is minus e to the power minus t. So that minus and previous minus will become plus. So the answer will be k e to the power minus t only. So it will become k e to the power minus t. And second term is minus 5k e to the power minus t plus 6k e to the power minus t. Check me if any error, let me know. Equal to 4 e to the power minus t minus 2 e to the power minus t. Now take e to the power minus t common from both the sides and cancel. So k minus 5k plus 6k equal to 4 minus 2 e to the power minus t. So your answer will be 2k, isn't it? 2k is equal to 2 or k is equal to 1. Correct now? All of you got this value?
Yes, sir.
So after finding the value of k, you will go back to your particular solution, that is equation number 2, and substitute. Now your particular solution will become 2 e to the power, sorry, 1 into e to the power minus t. That is nothing but e to the power minus t, because k is 1. So let it be equation number 3. Now you will write your forced response. Forced response is equal to natural response plus particular solution. And what was your natural response from equation number 1? It is C1 e to the power minus 2t plus C2 e to the power minus 3t plus your particular solution is e to the power minus t. Let it be equation number 4. This is your final equation. But we have to find C1 and C2. Now to find C1 and C2, what you will do? You will apply the initial condition. And how many initial conditions we need to apply? We need to apply 2 initial conditions because there are 2 constants C1 and C2. So students, all of you, find first you apply your initial conditions y f of 0 equal to 0. This is your first initial condition. So you will substitute t equal to 0 in the previous equation so that it will become C1 e to the power 0 plus C2 e to the power 0 plus e to the power 0 equal to 0 because your output is 0. Initial condition is 0. That is why you have equated that equation to 0. So wherever you are finding t, you will be putting 0. That is the first initial conditions that we have. E to the power 0 is 1. So answer is C1 plus C2 is equal to 0. Let it be equation number 5. With this, you can't solve.
So it should be -1, no, sir.
Yeah, e to the power 0 is 1. Correct. E to the power 0 is 1. So C1 plus C2 is equal to -1. E to the power 0 is 1. So C1 plus C2 is equal to -1. With this, you can't solve. So go for the second case, that is d by dt of phi f of 0 is equal to 0. Going for the second initial condition. So what you have to do, you have to take the derivative of equation number 4. So d by dt of what is your equation number 4? Equation number 4 was C1 e to the power minus 2t plus C2 e to the power minus 3t plus e to the power minus t. So all of you take the differentiation and then you apply initial condition and equate to 0. So taking the differentiation, you will get minus C1 e to the power minus 3t, sorry, minus 2t minus C2 e to the power minus 3t minus 2, right? Minus 2C1. Minus 2C1 because this is minus 2. E to the power minus 2t will be minus 2 into e to the power minus 2t. So that will become minus 2C1. Correct? C1 is constant, derivative of e raised to minus 2t. What it is? It is minus 2 e to the power minus 2t. So minus 2C1 e to the power minus 2t minus 3C2 e to the power minus 3t minus e raised to minus t. This is your derivative. Now in this we will apply t as 0. This is your d by dt of y of t or yf of t. In this, you are going to apply t as 0. So it will become minus 2c1 e to the power 0 minus 3c2 e to the power 0 minus e to the power 0 equal to 0. So it will become minus 2c1 minus 3c2 minus 1 equal to 0 or minus 2c1 minus 3c2 equal to 1, equation number 6. Now all of you solve equation number 5 and 6. You have two equations. One is c1 plus c2 equal to minus 1 and
Sir, C1 is -2 and C2 is 1.
okay. C1 is minus 2 and C2 is 1. So solving equation number 5 and 6, you will get C1 is equal to minus 2 and C2 equal to 1. All of you got this? I don't want to solve 5 and 6, that is left to you. You know how to solve the linear equations and all. So once you got C1 and C2, go back to our main equation number 4 and substitute. That is your final answer. What is the final answer? Can you tell me? Yf of t equal to minus 2 e to the power minus 2t plus e to the power minus 3t plus e to the power minus 2. Correct? Any doubts? So first what you have done is you have written the characteristic equation and found the natural response, that is equation number 1. After finding the natural response, you check the particular solution based upon your given input from the table. Then to find the value of k, you will be substituting in the given equation and you will find k. After finding k, you will again rewrite the particular solution, substituting the value of k equal to 1. Then you will add the natural response plus particular solution, that is the main equation number 4. In this equation, C1 and C2 are unknown. For this, we will make use of two initial conditions. First condition is yf of 0 equal to 0 and second condition is d by dt of yf of 0 equal to 0. So these two initial conditions we need to apply and then you have to solve the corresponding linear equations to find the value of C1, C2. Once you got C1 and C2, what you will do? You will substitute in the main equation, okay, and rewrite your answer. Any doubts? Okay, let me stop here. We'll continue on Monday. Okay. Thank you. Also today, 12 midnight is the deadline to complete your assignment 1. Okay. After that, no submissions will be accepted. It will be marked as 0. So this is out of 7.5 marks. So you need to ensure that you have to submit before your deadline. Saturday, 12 midnight. Thank you all.